This presentation focuses on the detection of the T2 mycotoxin using hydrogels. What is T2? So T2 is a mycotoxin, which is a kind of toxin produced by fungus. It is found in wheat, corn, oats, and human food. Ingestion of T2 causes vomiting, feed refusal, growth retardation, reproductive dysfunction, neuroendocrine disorders, and immunosuppression, and has been linked to diseases threatening human and animal health. Conventional methods for T2 detection, while successful, were time-consuming and complicated, which limited their real-life applications. As a result, these scientists set out to find a fast and cost-effective way to detect this dangerous toxin.
The method may seem to be complicated, but the idea is straightforward. Basically, after the authors extract T2 toxin from the food samples, they add T2 toxin into a solution called DNA hydrogel, which is a network of cross-linked polymer chains. If you are interested in what DNA hydrogel looks like, the picture on the right is the microstructure of it. DNA hydrogel will release a specific amount of a chemical called HRP according to the concentration of T2 toxin added in. HRP will interact with another solution that contains gold nanorods and other chemicals. The result is that the gold nanorods will be shortened by HRP. The picture on the right clearly shows how gold nanorods are shortened by HRP. At the end, the concentration of T2 toxin can be quantified by applying a technique called UV spectrophotometry to the gold nanorod solution. Just so that you know, this picture shows how the concentration of T2 toxin is converted to a peak shift by UV spectrophotometry.
This newly developed technique was able to detect very small concentrations of the T2 toxin, with a limit of detection of 0.87 picograms per milliliter and a limit of quantification of 2.9 picograms per milliliter. The limit of detection is the smallest amount of toxin that can be identified in the sample, so it's basically when you know that there's toxin there, whereas the limit of quantification is the lowest concentration of toxin that can be identified and reliably quantified. So you know that there's toxin and you know how much of it there is. This method of detection was also highly selective. Similar toxins were analyzed using the same methods, but shifts in the UV vis was only observed for the T2 toxin. In the end, the scientists were able to develop a new method for reliably detecting the T2 mycotoxin at low concentration. This method can be widely used in food safety and medical diagnostics.